Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland, and in this episode, we're going to be reviewing the latest complete OSW kit from Sim Racing Bay. And they're located in Slovenia. Now, he also sells all these parts and some extra accessories individually, so if you're building your own OSW wheel, you can actually source the parts from him also. So let's get to it. Now let's take a closer look at what you get as far as the components in a complete OSW kit from Sim Racing Bay. First, we'll take a look at this motor. Now, this is a Mige servo motor, and it is a 20 Newton meter. Sim Racing Bay also offers a 30 Newton meter motor, so should you decide that's what you want. Now, I think personally 20 Newton meters is fine. I'm running a Cole Morgan with 16 Newton meters, and it'll still hurt you. So, yeah, I think 20 is fine, but again, everybody has their own opinion about that kind of stuff. Right. Now, these are made in China, and they are an affordable servo motor, and they're actually coming out with the new encoders for these motors that make them even better, or make them feel better as far as the smoothness and precision. With the, I think this one has the 2.1, we'll look at it a little closer once we get there, but this has a 2.1 million CPR encoder on it. So I think that's the latest edition you can get. I could be wrong, there might be a newer one that's come out since this has. But anyway, there's ways, and that's one of the beauties of the OSW kit. You can upgrade as you want and at will as the new updates come out to the industry. Now, let's take a closer look at this motor. You can see it's got these fins in it in the casing, and it's supposed to keep the motor cooled down. I haven't run it yet, so I don't know how hot this motor is going to get, but we'll find out when we get there. And it's a very heavy piece when you're trying to move it around. It's got the peculiar, to me anyway, because I'm used to running Cole Morgans, the way that they've set up the plugs here. And we'll go ahead and pop these rubber covers off. And you can see that the one back here is where the encoder is, and that's where we have all these small data pins. And over here we have the larger prongs, which actually are the power supply for the motor itself. Right. So, again, we're going to pull this cover off the encoder when we get to the look inside part and just take a better, more precise look at what's going on there. So yeah, nice motor to have, very heavy, so you're going to need something substantial to mount this to. So remember that. And again, we'll get to the particulars of this motor as far as weight and things once we get to the details. We also get this cool controller box. Now they also offer a Cool Master. It's the metal computer, small computer box that they put all the internals in. But this order included the Granite Devices, well, it says Granite Devices on it, but this is the custom plexiglass, smoked plexiglass enclosure. We'll get a closer look over here. And you can see it says SimCube on the top of it. And it's kind of translucent. Obviously, you can see in there what's going on. On one side, we have the cooling fan. On the other side, we have the exhaust vents for that cooling fan. So keep everything nice and cool in there. You can almost see what's in here through it. Of course, in these video lights and stuff, maybe not so well. But we're going to be taking this apart anyway. You can actually see the back of the power supply. I think that's the power supply in there. Anyway, we'll get to the particulars and details once we take it apart and look at it, like we always do here at the SRG. We've got a couple of USB ports here. We've got some RJ45 points here, and we've got the ports for our data and power cable on the back here also. And of course, we have the main power switch there. And really not much else to see here. It does get fingerprints though, so one thing about these plexiglass numbers, the fingerprints are easy to get on there, but easy enough to wipe off too. I really like this case. It's something different than the normal cases you see everybody using for their OSW builds. So yeah, I kind of like this, but we're going to pop it open once we get to that point and see what makes this thing tick. Right. So what else we get? We get these cool cables. Now, the customer that ordered this, now this, by the way, is on loan to me from a fellow iRacer. Okay, so he's kind enough to order this brand new and have it shipped directly to me so I can do a review, and then we will ship it to him once I've finished with my review and get it all set up for him. So when he ordered it, I always recommend to order these kind of cables. These are the shielded cables, and we'll get a close look over here, and we'll do the suicide button too, kill button. Right. So you can see this cable here. Instead of just using the regular cables that you can get, that a lot of companies will use, or a lot of guys use rather, in their OSW builds, which really doesn't matter. But to me, I always like to get the shielded stuff. And this is really nice shielded cable on here. and that keeps you shielded from the EMI interference. It's very possible with this OSW builds. I've read more than a few instances where in a new OSW build someone was having problems with all kinds of little gremlins happening to their inputs, their games, or whatever, the hardware they're using. And this just helps eliminate the potential for that. I'm not saying it's going to eliminate it completely, because there might be other things causing it, but for the little bit of additional cost of adding the shielding to the cables, the motor cables and the data cables, it just seems like a no-brainer to me to go ahead and do that. You're already buying the system anyway, so yeah, I really like that. And you can see that this is the typical Mige connector, 90-degree elbow, very industrial type of a connector. I really like this. I like the industrial stuff. If you watch my videos, you guys know that. And of course it has the 4 pins in there that will go onto the motor over here. Now on the other side we've got the power that goes into the actual power supply that's on the box, that we'll see that later. And very neat. I like this end here. You can see it's kind of like a machined steel here. You can still see the machining grooves in there. I think the camera will pick that up okay. And then of course we're also using this to kill the power, because you can see this black cable is actually made into this plug. So we've got some pin outs on the plug here for our, I call it suicide button, so you don't commit suicide. So that kills the engine, or rather the motor over here, if we have a problem and it starts spinning out of control or something like that. It goes beyond the stops we've programmed. And anything is possible with these things, so it's always good to have this on your rig very close, so in case something happens, all you have to reach over and slap it. I actually have mine mounted to the side of my rig, so I can actually reach over with my knee. My right knee is on the accelerator pedal. I can actually reach over and just go pop and stop it right there, so I can take my hands off of it and don't have to try to grab anything or reach around it. Anyway, that's how I did it. We also have the other cable over here, and this one is also shielded. And I got some writing on here. You can see that it's very nice stuff. You guys can read the printing on there. Yeah, so it's actually I don't see how you wouldn't order it this way, because it's just avoids problems that could arise, and you spend hours troubleshooting them. Right, so obviously this is the data plug. Same kind of plug, just has the smaller pins in there so we can send and receive data. And obviously this is the DIN socket that goes on the back of our controller box. Very nicely done. I mean, you can tell the little gables in here are very nicely done. Let me show you that. So the stress relief, so we don't rip anything out of here. All these are nice connectors, high quality. No cheapy plastic stuff here, which I like. All right, more cables. Obviously we get a power cable. Probably don't need to look at that, because it's just a regular power cable that goes to the power connector. All right, we got a couple of USB cables that came with our kit. That's very nice. They included some USB cables. We're going to need 2. And these actually are the ones that don't have, I can feel in the package here, there's no ferrite sinks on here, if you will, to help with EMI, which I would have preferred to have cables that have the little ferrite modules on them, so we can even further reduce the EMI potential of these kits. But that doesn't have them. But you can always get the snap-on type and put on there if you have some issues. But hopefully the shielding on these cables is going to alleviate that. Right. Talk about the mounting. Here we have the front mount that's going to go on, obviously, the front of this motor. Just like that. Take a close look over here. There we go. So this is actually going to fit over the ring here, and actually I had to pick it up to make it happen, because it sits up a little higher. But there you go, you can see it now. So it's sitting in here flush with this circle. So a nicely done bracket right here. Actually, when I took it out, I really liked what I was seeing because of the powder coating on all the bracketry here. This is very nice powder coating. In the other 2 pieces, let's grab that. Okay, these are the side mounts that are going to give us the adjustability we need. Let's go ahead and get this motor out of the way. And they will mount to the sides like this, right? So we can actually adjust up and down. There's the hole there. Up and down for the angle of the motor. Unless you have some kind of a adjustment on the mount that you're actually mounting your motor to. But again, nicely done pieces. Very nice powder coating on this. And there's a little bit of scratching on there. I can't tell if I've done that already or not just by messing with it. Probably, because it looked pretty good coming out of the box. Again, very nice stuff. Only defect I found so far in this after going through it was right here. You can see that. There's my pointer, my help. You see there's a bit here of metal. And what that is where it's left over from either them drilling or punching the holes in this metal plate here. And it went to actually had to go to powder coating like that also. And you can see the powder coating has already come off. Maybe something's rubbed against it. But if you'll notice in this hole, I'm going to have to do something about that because, let's go get some light on it. You can see the little bit more of metal that's left in here. Not a big deal. I'm just going to get a rat tail file and just smooth that out so the bolt will go in nice and smoothly. But before I do that, chances are when I start filing on it, it's going to make this piece come loose. Oops, there I am. This little piece here is going to come loose. So what I'm going to do is I'm going to trace that piece with a straight edge razor and cut into the powder coating, because you always run a risk when this comes off of some of the more of the powder coating coming off too, even though that's a hazard with any of this stuff really when you're messing with it, powder coating coming off. But that's just one little defect that I did find. And you know, it's when it comes to stuff like this, I would have liked to seen this not be here. It's just one of those things that, you know, it makes things look better when you pull them out of the box if you don't have something like that to look at, right? Okay, so that's the brackets. Oops. Now we got our mounting hardware that comes in a bag, and this is just some screws, and we'll look closer at that as we're actually mounting all this stuff up. And we also have the mounting for the motor shaft, this bugger here. And I'll show you that over here on the other camera. Right. So this unit, you can see it has 4 bolts on it, and we'll get into detail as we mount this, and you can watch it cinch up. And basically what it's doing, it's pulling. This is actually a 2-piece unit. If I take all 4 of these out, this comes apart. And we have an inside piece that's part of this, and then we have this outer ring here. And the whole idea is we're pulling this close onto the, actually pulling it close together. As these 2 pieces come together, this piece inside, if you can see the groove in there, that will actually close up on the shaft. And once you torque these down in sequence, you get a very, very nice tight fit with this kind of a clamping mechanism. I have the same thing on my core. Well, not exactly the same thing, very similar as far as functionality is concerned, but it looks different. But same thing. You're just pulling these 2 pieces of metal together, and as you do, it squishes that ring, so it makes it real tight on our shaft down here. Very good, very cool. And then we got some spacers here, and how this is going to go together is this piece is going to go on. First off, we got this going on the motor shaft like that. All right. Then, tell you what, let me jack this up a little bit with my piece of wood that I have conveniently located here. All right, so we got 4 center holes here, or 1 big hole, then we have 4 around the sides. Then we've got a regular 70mm bolt pattern that'll fit a steering wheel or whatever, adapter, quick release, whatever, on the outside of that. So what we're going to do is we're going to put this, take all these screws out and put this on, and then put the screws through those holes, and then tighten this down onto the motor shaft. So we'll have this whole assembly sitting with 1 piece. Then we're going to take, because we do this, obviously, we're going to have these cap screws sticking up past the flat part of this. So we've got a nice little adapter here that's going to go over those heads. Now, this is what they actually do. You can see how it's cut out. Got the rounded pieces here, and that's so it'll fit over those cap socket screws like that. But of course, we'll have this in the way, and they'll be on top of that, and then we put this on, and now we're ready to bolt this, because this all lines up, as you can see. Let me put this here so you can see all our holes. These are all 70mm spaced holes there too. So then we have this whole assembly there. Then we can mount our quick release to this, or you can mount a wheel directly to this, however you want to do it. Or you can mount this Fanatic adapter. To give a good example, let's say this is my wheel side, or this is not the wheel side, it's the motor side of my adapter assembly, and then I'd put that on top of that. But I'm not going to be using this. Speaking of this, now that we've actually gotten to it, this is a cool piece here. This is a solid stainless steel piece of CNC beautifulness. It's just, I love this kind of stuff. It's so well done. You know, it's even got the chamfering on the outer edges of this. And this is a Fanatic adapter, so we can put this on our motor and actually take our Fanatic wheel. Obviously, the Fanatic wheel is going to have to be a USB converted one because we can't use Fanatic stuff on the OSW. But anyway, once you have that converted, then you can leave your regular Fanatic quick release on and use that on here, because you can see this is actually a duplicate. You got the keyway up here, the guide, if you will, that's on the Fanatic wheel side. So yeah, of course, this it has places for electronics in there too if you're going to use it for something else, but we wouldn't need to use that. And of course, it has the 70mm spacing. But this is just a gorgeous piece of CNC stainless steel. It's substantial in your hand. It really feels great. I really like this, even though I won't be using it. So, what else we get? Let's see, this is part of that, so we'll put that back. And this, I meant to tell you guys, is a retaining ring that fits on the back of here. And what that does, you can see how loose this is? And what that does is when we compress, start pulling this in, and this is the outer one's going to go out, it keeps it from going too far. So it's a little retaining ring, so it keeps this from, this groove here, from expanding too far. Right. So that's about it. That's all you get in a kit, and really that's all you need in a kit. So what we're going to do next is we'll start getting to each separate component. Well, basically we're just going to do the case and the motor itself, because we're going to have a look at this nice encoder back here, this 2.1 million CPR encoder, which I believe is the highest resolution encoder currently available for the Mige motor. So we're going to have a quick look at that, and then of course we're actually going to open this box up and see what kind of parts they've used to configure this, the Ione board and things like that. So we'll get to those segments next. Alright, we've got the box opened up so we can see all the components inside. And when you open this box, because of the way it's modular as far as all the pieces that form the box, everything's very loose once you do that. So you want to be mindful of that if you have it apart. And anyway, let's take a look around in here. First thing that I noticed about this when I opened it up was how neat and uncomplicated it looks. Here's a couple of pictures from 2015 when I did the direct drive force feedback wheel comparison video, and this is an OSW, a custom OSW box, and it is very busy, as you can see. It's got all kinds of wires going everywhere. We had a bunch of little wires going to the Argon K400 controller up there. That, yeah, it's a lot of stuff going on. There's a big gold fin resistor back there, a braking resistor. And then of course we had to put a STM32 F4 Discovery board on there also. So yeah, there's a lot going on there. And then when you look at this, it's just amazing how far it's come. Now it's all on this little motherboard with the little motor controller up here. And we'll get a closer look. First, let's just take a look at the power supply that they're using. And I'm going to try to keep this from falling apart, obviously. And it's a Meanwell, which is very good stuff. A lot of people use this because it's an industry standard. Bodner actually, in their case, they are actually using a Meanwell also. And this is a 480/48, which means that's 48 volts at 10 amps. So that's 480 watt delivery. Now, we got some wires coming out here, but this is coming from the mains, and you can see the mains down in there. And of course we can see it on the other side here too. That's where the mains comes in. It's got our switch over here, and of course the other stuff that's on here for plugging in our data and power to the actual motor. And yeah, very nice power supply. We've got our DC outs here. One is actually just a ground. You can see it's actually got a screw on there, so it's grounding to this main lug here. And of course we've got the positive negative going to the other pieces there. Now you can read the SimCube logo on there, and we can also see these huge stack of 10 watt resistors. You can see these are the big, these are not the ceramic ones, these are huge because of the power coming in. And of course this is part of the power circuit of the board. Then we've got this nice capacitor up here. It's a KYB 63 volt 1200 microfarad. You guys get a look at it that way. There we go. So yeah, this is just a great board. Little ARM chip on here running things. We got this little daughter board up here. We also have, before I get to that, we also have some dip switches, kind of holding this up here, back in there. And I'm not going to mess with those because they're already set. Everything should be ready to go in this box, including the firmware already loaded. And here we have the driver board. And this is a, let's go ahead and just pop that out real quick. It pops in and out just like a memory stick in a computer. So very easy to do this. And you can see it's the Ioni Granite devices. And if we flip this around, we can actually see that which kind of board this is. And of course you can see up here it says this is the servo drive, and that's what it is. And remember, the Argon K400s were huge compared to this thing. But it also has the designer's name on the bottom. That's the first time I've actually seen that. Usually you just say, you know, it says by, or not by, but you can see down here that the year was 2016 when they designed this. And there's the designer's name on there. Very cool. On the side here, you can see these two X's have actually put on the board. See if I can get that close enough you guys can actually see it. And above those X's, there is a Pro and then an HC. And the Pro and the HC is for high currents, and a Pro, of course, is for the Pro board. This board will also work with the 30 Newton meter Mige motor. But you will have to get a different power supply that'll do a peak of 780 watts, I think it is, or 720, something like that, to be able to get the most out of your 30 Newton meter motor. Although you could run it on this. Right. Easy enough. Very cool stuff. All easy to replace. If this burn out, easy enough to take your cover off, pop another one in. We'll go ahead and just pop that back in securely. And anything else we want to see on this board? Really, there's not a whole lot to see here. It was a lot more fun with the other one, I think, with all the stuff going on, all those separate components. And now it's all on one board. It just kind of takes away from the excitement a little bit. Very cool, though. It's just great to see how things have progressed over a 3-year period. Just 3 years, we've come to this. It's just amazing, really, to me anyway. Got the fan over here that's going to be blowing on the silent. This is a silent power supply, which means there is no fan inside of here. But this is just things keep things nice and cool, because we're kind of going half and half here the way the fan's mounted. Some of the fan's going to be blowing on the power supply, and the rest of it's going to be going across the board, across these resistors and stuff. Right. Wow. Pretty simple, huh? Doesn't get much simpler than this. Wow. The ports back here are for your USB, and we're going to have both of these USBs plugged in. You can run it with one USB, and because that's just the force feedback USB, but there's another one here that's for upgrading the Granite device in here with firmware. So we're just going to have two. It's easier just to have two plugged in all the time. That way you don't have to start taking one off, put it in another thing, then update your firmware, then pull it back off, put it back on the other one. Yeah, it's just a lot less hassle there. Right. Of course, we have our 15-pin, 15-pin DIN, and this is for the data port. And over here you can see these bigger lugs in this one. And of course, that's going to be for our power, and also, yeah, just power and ground for the motor. It's a couple of different pins there. Right. And there's also these two pins over here. We can actually look down in here, and it tells you what these pinouts are. Very cool, because at least you know exactly what's going on all the time. So the pinouts for this are going to be positive and STO, but that's for the E-stop. So those two pins right here are for your E-stop. And remember, if you saw that plug we plugged in, or we're going to plug in rather, when we were looking at what comes in the kit, it had the actual E-stop wired in with the same plug, along with these other 1, 2, 3, 4. Yeah, there's 4 power plugs on there, or power poles. Right. Well, simple stuff. You got your mains here, little protected fuse protected unit. Very nice. So yeah, that's it. So now what we're going to do is go ahead and next we'll just get the motor out, the Mige 20 Newton meter, and we'll do a little comparison while we're at it. Since I'll have my Cole Morgan off anyway, so we'll do a little bit of comparison on weight and dimensions and just how they're built in general, and then we'll get on to mounting and driving, hopefully. So we'll get to that next. So now let's take a little bit closer look at this motor than we did before and get some measurements on it and see what this thing looks like. First off, I'm going to hold this up so you guys can actually see the information on the label. As you can see there, it actually says under Newton meters 10. So I'm not sure what's up with that, but it's supposed to be a 20 Newton meter motor, and I'm sure it is. But I'm not sure why they put 10 on there. unless there's some kind of a reduction gear system going on inside of this or something that increases it. I don't know. So anyway, there's the label. And there's a keyway on this motor shaft. You see it right here. Obviously, for our purposes, we're not going to use that keyway. And it comes with a loose key in the box when you buy this motor. But we're not going to need that because we have a cinch down type of clamp we're using for the shaft. Speaking of the shaft, let's see. It's a pretty thick shaft, as you can see here. And obviously it's going into a sealed bearing in there. And curious about this motor is it looks like it's bolted together. You can see here these bolts in the front, and we also have some bolts in the back. So it's like it's two halves that are bolted together into this housing here. You can see this is a cap, and apparently this is a cap too, and we've got this extruded aluminum housing going around everything. So to work on it looks pretty easy. Just take the bolts off. Comparative to like a Kollmorgen, and we're going to look at a Kollmorgen in a second here just to compare a few things. Alright, first off, let's get the dimensions of this motor. It's not a very small motor, as you can see. And I'm going to use my trusty machinist ruler to do this. And all the way from side to side, as far as how wide this thing is, it looks like about 128, 29 millimeters. Okay. Or for our friends in North America in the fractional system, about 5 inches and maybe a 1/16 in there. Right. So, and of course this is completely square, so it should be the same all the way around, like most of these motors are. Some of them are a little different and they're not equal all the way around, but it looks like this one is, yeah. Another 5 1/16 there. It's got this raised aluminum piece up here that will actually go into the bracket that we've looked at before. But I'm not going to be using that bracket, by the way. I am actually going to be mounting this directly to my SimLabs P1 15 millimeter motor mount because it accepts, apparently, the Mige. I know it accepts the Kollmorgen because I've been running it. But yeah, I was relieved to find out that that was actually on there, so I don't have to mess with the mounting bracket. But let's see, the shaft, obviously nice and big, thick shaft there. And having a nice thick shaft obviously gives you better resistance to deflection of the shaft. So yeah, even this will bend, believe it or not. It's solid steel, but yeah, it'll still bend rather. It won't build anything, but it will bend. And also that improves the force feedback fidelity that you get back from this motor. Some motors, if they have a smaller shaft, let's say you had a 1/2 inch shaft versus this almost 1 inch shaft here, then yeah, that's going to be even more subjective to deflection when the motor is moving. So it actually will cost you a little bit on the force feedback fidelity or precision that you get because it's going to be lost a little bit in the flexing of that shaft. Believe it or not, that is true. Now, whether or not you're going to be able to feel the difference, well, that's another argument for another day. But let's just see how big this shaft is. Got my micrometer here, and we'll put it on millimeters, seeing as how all this stuff is millimeter. All right, good. So let's see what we got here. All right, you guys can see that it's 22.1. Hopefully that's showing up on the video. 22.1. So that's a pretty thick shaft. Now if we did let's go back to fractional, and it looks like 0.86. So yeah, almost an inch. Not quite. Inch is more like 24, I think. Now let's compare that, seeing as how I just happen to have my Kollmorgen handy, and see what it does as far as the measurements. So this is, yeah, 0.94, so yeah, that's almost dead on an inch there, if you guys can see that. I'll move this way to show it better. There we go. Right, and if we go to millimeters, it's actually going to mic out to 24.2 or so. Hopefully you guys can see that one too. Right, so a little bit thicker on the Kollmorgen, but look at the difference in the size though. This thing is huge compared to this thing, but this has got a thicker shaft on it. Go figure. I don't know. And they definitely feel different when you move them. This feels, I don't know, it's easier to turn. This one's a little bit harder to turn. Of course, this motor's been in use for a while, and this is brand new, so that might actually loosen up a little bit with use as the bearings break in a little bit. Because, yeah, this one is definitely easier to turn than this one. But this big guy is heavy. Heavy, with a capital H. How heavy do you say? Well, let's find out here. Let's let this thing calibrate. Our trusty weight here, or scale. All right. All right, here we go. We're on kilos right now, so let's see what that is. Wow, 10.07 kilos. That's pretty heavy, and for something that I can relate to, being over here in North America, let's go just to pounds and ounces. Wow, 22 pounds and 3 ounces. So that, guys, will give you a general idea of why you need a very stiff, substantial mounting platform just to hold the weight of this motor. We're not even talking about the torque that it's going to put out. Just the weight. You got to have something substantial for this kind of a mount, or mounting this kind of a motor. Let's see, since we got it out. And by the way, this is a Kollmorgen AKM 52G. You guys can read the number there to make sure I'm telling the truth. There it is. All right, so this is 12 pounds, 13 ounces. It's, you know, it's getting close, 13 and a half. It's just a 2.5 away from another pound. So we'll say 13 pounds on this one. Still, 13 versus 22. Yeah, in 3 ounces. That's almost, that thing weighs 10 pounds more. All right, kilos. Now we're at 5.840 or 5.820 if it makes its mind up. There, it's settled on 2. So yeah, definitely a lighter package. Now this is a 16 Newton meter versus the Mige over here, which is a 20 Newton meter. So yeah, it looks like 4 more Newton meters cost a lot more weight. But then again, of course, they're completely, these are actually a little different. You know, they're both brushless servo motors, but as you can see with all this space in here, that this one is constructed a bit differently than the Kollmorgen is. For better or worse, that's the way they are. Right. So now let's get the Kollmorgen out of the way. Let's do something. Now this has got the, and the only reason I'm doing this is because this has the 2.1 million CPR encoder on it. And you can see it's pretty easy to get to the encoder. It's only 4 screws here on this little housing here. So this whole thing comes off. Now, of course, the data cable is also in here, so we have to be careful if we do pull it off, because we know there's going to be a cable in here somewhere attaching to the encoder and any other electronics going into the motor. So we have to be careful when we take this off. But I just want to take a peek at this, and because we can, we will. I think that's a 3 mil. Yeah. So it's a 3 mil screws on the back of this thing. So I'm going to go ahead and take these off and see what's in here. So bear with me real quick here. Shouldn't take too long. There's 1 screw. And these are just 3 mil regular, feels like just a regular steel socket head cap screw with no washer. I think the rest of them have washers on them. Let's see. Put that over in the magnetic dish so I don't lose it. Let's go ahead and grab this other one on the bottom here. Here we go. Yep. So this one actually has a washer on it. So it looks like whoever put this encoder in, and they probably do that at Sim Racing Bay, because I imagine from the factory they come with the stock encoders. So yes, it looks like somebody lost a washer there. All right. Let's take this one off. Same thing, washer. Good, good. And I can see there's a washer on this one here. Right, so that's just 4 screws, and we should be ready to see what's in here. You know, I just kind of, oh, look at it, almost fell off in my hand. Gotta love it when it's easy, but you still have to be careful too when it's easy, because you don't want to lose anything. But yeah, there's a cable in here, obviously. Let me flip this around. And there's the business end. That's our encoder. All right, which is really pretty easy to replace these. Let me lay this down for a second. Actually, it'll kind of rest on that cap. There we go. So it's real easy to put another encoder in, which is great about these motors. And I imagine the Kollmorgen is the same thing. You just got to get the right encoder. So it's just this bolt here bolts it to the actual shaft running through the motor, obviously. Then we've got these 2 guys here that are holding the bracket that actually holds the encoder. I'm going to try to spin this around so you can see what I'm talking about. Best I can, anyway. And there you go. I think you guys can see that. I wonder if you can see the encoder moving, or not the encoder, but the motor shaft is in here. Let's see. Yeah, there you go. See that? It's got some flat spots on the bolt or whatever it is on that shaft, so it's reflecting the light when it moves. So that's the shaft moving, and you can also see that the screw is actually moving on the back here too with that. And that's what you want to see. Obviously, that means it's working right. It's supposed to. Right. So you see there's only 3 screws to take this encoder off and then put another one on. And usually the encoders come with their own cap assemblies with this thing already wired up. So all you have to do is take the cap and the encoder, and comes off as one piece and goes on as one piece. Very neat. And this is just some labeling here, and I've actually looked at the labeling. I was trying to show you guys this, but it's really not much to see here. It's just telling you what the wires mean as far as volt, data, or whatever they're doing. But I'll just take a little look at it there. Maybe you guys can freeze frame if you want to read that. And it's just basically the wire pinout in the manufacturer's name. Right. And we got a little kanji letter up here for something. Maybe that's an inspection right up here. Maybe that's the inspector saying everything's good to go on this. I don't know. But you can see it's actually on the cap too, wherever they put that. It's like a paint crayon or something they used. Right. So there we have it. Not much to see here really, because it doesn't move, but the shaft, obviously we saw that moving. So yeah, this is how easy it is to change an encoder. So it's nice to be able to, as new encoders come out and we get updates, we can actually take this one off and put maybe a 4 million CPR encoder on, which is like what is over here in this Kollmorgen. Actually, the version 2 of the Sim steering comes with the Kollmorgens, and supposedly they have a 4-point-something million CPR. And remember, CPR and PPR, well, PPR, a 2.1 million PPR is more like 550 million PPR. Or did I say that right? CPR. CPR 2.1 million would be, a fourth of that would be PPR because of the way that, and you can look that up on the Granite Devices wiki if you're really interested in that kind of stuff and see what the differences are. And most marketing, I think it's more of a marketing thing, even though some people say, well, we just measure it this way and we measure it that way. But yeah, it sounds much better saying 2.1 million or over here the Kollmorgen 4 million than it does, like this would be like a 1 million PPR over here. And this would be, again, like I said, like a 550,000 PPR. But regardless, however you want to call it, that's the way it works. Now, we'll go ahead and put this cap back on, and when we do that, obviously, we're going to make sure the cable is routed properly and the cap's going on like it should, and it should just fall right back on there like that. Beautiful. That's what we like to see. Right. Oops. Right, so now all I've got to do is put my screws back in, get this lined up a little bit here. Man, this is a lot easier than I thought it would be as far as putting it. I've never put one in. This is the reason I was wondering. So I'm kind of satisfied in my own curiosity, along with showing you guys some of this stuff, if you're interested in that kind of thing. So we'll go ahead and get this cinched back up pretty quick here. Now, I said before I'm not going to be using the motor mount that came with this kit because I have a SimLabs P1 chassis. And if you guys know that chassis, it actually has an option of a motor mount. And he just came out with a new one that's 15 millimeters thick. I mean, this is one heavy-duty motor mount. So yeah, I'm going to mount it to that instead of mounting it to a flat plate. And whoops, that's the wrong bolt. To a flat plate, and which I could have. And in fact, there's a lot of people who do mount it that way. Kind of hold this up here while I get this thing going. There we go. And I have a plate that would do that, but yeah, if you can go ahead and use a 15 millimeter plate, all the better, because you know we at SRG, the one thing we hate is flex, right? It's the F word for Sim Racing Garage, flex. Yeah, we do not like that. And you really don't have to over tighten this stuff, just snug it up, because as you can see, this is just a cap. It's a dust cap, if you will, basically. That's all it's doing. And it's also providing a mounting point for our plug cap here, or where we're going to plug everything in. Right. So the shaft on this is, we're going to actually use this to attach, and you can see how if I slide this on here, it's pretty snug. Well, let's take this off. Oh, let's take this thing off. That's the retainer to keep it from getting too big. And you can see it's nice and snug before we even start cinching down anything. just as an example of a difference, this is the same kind of principle. It cinches down too. There's a conical shaped piece here that's part of this. Same thing here. There's a conical piece in here that is part of this. And as we bring these two pieces of metal together, then it squeezes that conical piece where it has the groove in it there. You can see it right there. We'll squeeze that down on top of the shaft and really cinch down really well. You don't need a key at all when you have this, especially for our purposes using a steering wheel on a servo motor. Now, if you were turning a big piece of gear or something, then you might want to use the keyway, depending on your situation. Same thing here. It's a conical piece in here, and as we screw these bolts in here down, it pulls this piece up on top of it and cinches it down. Works very cool. Now, I'm going to go ahead and, while I'm doing this real quick, just to go ahead and put this on and show you guys how I'm going to do this. I'm going to take these bolts out, and these are 5mm socket head caps. And the reason I'm taking them out is because I'm going to have to put this adapter on there. So it turns this little 4-hole pattern into a 70mm pattern. And of course that comes with the kit. Now, another thing, before I do that, I want to show you guys, to get these things off, as you might imagine, it can be tough. Just taking these bolts out doesn't mean that these two pieces of metal are going to come apart at all. In fact, they're pretty tight right now. And it's a good time for me to give an example of how there's a self-separation thing going on here. These bolts actually came out of the 4-pattern holes. But I'm going to put one in each one of these opposing holes here. And that's how we remove these things, or separate them and get them off our shaft. And let's see, that was a 5, so let me grab my 5 here. Do I have it handy? There it is. Now, I don't know if this is going to be, and now all you do is take it once they're in, and you can see they're right through there. It's going through here and going to push on this piece. And of course, it's come loose now as soon as I tapped it a little bit with this, so it wasn't very hard at all. So now that it's loose, it'll slide off, and now we can take everything off. But you can see, here's what I want to do. I did that. I want to show you the conical shape I was talking about. See how that is? So yeah, as this gets pulled on top with the bolts, we'll go ahead and get these guys loose. Get them out. I'm messing up my view here. Right. So of course, as we pull these bolts in on the holes and pull this, sandwich it together, it pushes down on that conical piece inside. And that's where we get all that grip. And in this particular model, we have a slot here and we have an opposing slot on the other side, and that's how this works. Now, funny thing is, the one that Sim Steering sells doesn't work that way. It has a slot all the way through this one piece. So that other piece, other slot that you see there, there it is, it's all part of this one piece here. So this little disc here is all by itself. And it also has these two little holes here and one here, to press these pieces apart so you can get it back off. Very cool, the way this stuff works. So once we have this off, obviously all we got to do is, again, for this particular one, we want to make sure that these slots are opposing 180 degrees out of phase of each other, if you will. See, like that, or close enough. And we'll just kind of slide it on here. And you can see we could slide it down and have the shaft sticking out, but more than likely that's going to interfere with our adapters and stuff. So I'll usually just bring it out maybe a few mils past the shaft before I start my tightening process. Now again, we're going to have to use this adapter. So we'll do that. All you got to do is, and you can see that it's kind of a flexible adapter because of these big, it's kind of a big slot it has in here that allows this bolt to move around pretty easily. So we'll go ahead and just start this. Get them all started. Now, when you're first starting it, you can go ahead and press this back further, and you can see this front of the shaft is actually holding that adapter on there while we're doing our cinch up. And if you see here, the way I put this adapter on, it's not going to work because I don't have any holes there, and there's other two holes. So, again, the adapter can only go on one way, apparently. So we'll just turn this until we get all the holes lined up, which would be here, here, here. There we go. So now we should have our holes lined up. Well, actually, we got to get them lined up. That's the problem. See, they're not lined up with this back piece. So we got to twist them a little bit to get them lined up. All right, now we should be able to get this on here. easy. There we go. Here's 1, 2. It's all pretty easy to do. And now that I get them tightened down, I'm going to go ahead and slide this back out to the front and get that couple of mil clearance from the shaft to the front of this, right? So now that I've done that, I can go ahead and start tightening them up. And I'm not going to get it totally tight here. I'm just going to show you how this does bite down once you do it. And you kind of want to do a pattern here. I try to do a little cross pattern when I'm tightening these things as I'm cinching this down. And as you cinch it down, these will come loose as you tighten the other ones up. So it's kind of you just keep going back and forth and start tightening and tightening. And there'll come a point where this thing will actually get tight enough it starts cinching down. I can feel it now. The friction's already grabbing on it a bit. It came out on me while I was doing that, so we can use to tap it back in and get it the right distance we want. And now it's getting tight. Almost there. And of course the final tightening I won't be doing with this because you can't get the same kind of torque you can with, say, one of these bad boys. Our standard familiar looking wrench, even though this does have a ball end on it. So once we get to a certain point, then I'll be using this to snug things down a bit and just start working it around. Just like that. Pretty simple, yeah? Right, so once we have this good and tight, and it's not all the way tight yet, because every time I go to another one it's loose, then I know it's not tightened down all the way yet. But it's getting there now. Just start working it around. Pretty easy. A little time consuming, but that's about all I'm going to do right there, I think. Isn't that tight enough to turn that? Yeah. All right. It's pretty tight now anyway. No way I could ever pull this off. So yeah, that's the end result. And you see we do have a little bit of shaft sticking under the plane of that plate. So the only thing we got to do now is take this adapter, and this is a special adapter. It comes with a kit. And you saw this before if you looked at the closer look. And this is made so it'll flip over these bolts. The bolt heads, rather, just like that. So that gives us enough spacing, theoretically, to actually put what we need on there. And I'm probably going to take all this apart again later and before I do final assembly. But then once we have this spacer on here, then we can actually take our other adapter, whatever we're going to use. In this case, I'll be using this guy because this, if I'm going to be mounting this to my P1 chassis motor bracket, I know this is the distance I need for spacing. So I'll just take this and we'll just run our bolts all the way through, and then we're golden. We're ready to go. This motor's ready to mount. Right. So, anything else I want to look at here? I think that's about it. What we'll do next is we'll just go ahead and take a look inside of this guy, I think, next, once we get everything finished up on the wheel here, or the motor, rather. So now we have to get this motor mounted, now that we have our clamp securely attached to our shaft. You can see right there. And of course, remember when we put this on, first off, there was this ring right here. Let's go ahead and get this whole tray of goodies out here. There was this ring that was on the back of this. Well, when I put this together and really tightened down on this, I mean really have this really tight now, this ring was still loose. I couldn't tighten this down enough to make this ring stop jingling around back there. So it was just too loose. It just wouldn't tighten up on it for whatever reason. So I took the ring and took it off. So now I retightened everything back up. And remember, to get it on and off, all I had to do was use those two holes back there and kind of press it back apart. These two pieces of metal came apart and everything worked fine like it should. And yeah, so yeah, no ring, but I don't see where the ring's going to really help anything anyway in this condition. It's just going to be shaking around. It's no good. So we took it off. So if you get this, you're probably not going to be able to tighten it tight enough, this assembly, onto that shaft to keep this from spinning all around and going crazy and making noise. So off it goes. Right. Now, remember, we're going to be using the spacer here because you can see how the cap head screws here are sticking out. So this little spacer with the little cutouts for those cap head screws is going to sit there like that. They're still protruding just a bit, maybe 2 millimeters, 2.5, maybe 3 mils, or maybe a 1/16 of an inch or so. But I don't have any problem with that because I'm not mounting something that's perfectly flat against the face here. I'm mounting this, which has a hole in it. And guess what? That hole obviously is larger than that bolt pattern there, so I don't have any problem. Go ahead and put my 6 little screws and nuts on this, and I'm good to go. And this is obviously what I'll be using. So, just want to discuss that with you real quick before we went to the actual how we're going to mount this. Now, it comes with this nice powder-coated piece here that you can use for mounting to a flat surface if you have that. But I happen to have something a little better than that, so I'm not going to use this. I have this massive 15 millimeter thick motor mount that came with my SimLabs P1 rig, right? So obviously I want to mount it to this instead of just the flat plate that I have for it. Right. So the good thing about this is it actually fits the Kollmorgens and it fits the Miges. Now I'm pretty sure it's going to fit a lens too. I think these grooves that are cut in here were made just for that, so all these different motors would still be able to fit onto this bracket. Right. So I've done this a few times with my Kollmorgen and some other things because I'm always doing these reviews and switching motors around. So I have a system that I use, and of course there's probably 10 or 12 different ways to mount this motor here. But this is such a heavy motor. What I want to do is pre-mount it to this before I go over and put it on the P1 rig. That seems to work better, and because trying to hold a heavy motor up while you're trying to get bolts started can be a pretty big mess sometimes. So I'm not going to do that. I'm just going to mount it right here. So another thing I got to consider here is you notice these these plugs, especially the top one here, sticks way up in the air compared to like the Kollmorgens. Yeah, and they don't stick out quite as much, but it's a bigger motor too. And I've got these triple monitors that are going to come. I like to bring them real close to the back of the steering wheel. This is not going to allow me to do that, but it's simple enough. All I have to do is turn it sideways when I mount it. So now my plugs are sideways. I'm good to go. We've just got this top here. So here's what I'm going to do. I'm actually going to take this, set it aside, and I found the best way to do this. And the bolts they sent, where are my bolts at, with this kit, aren't going to be long enough to go through this thick 15 mil piece and then go all the way through this piece, the flange here, and still have enough thread back there. But I'm in luck because I have actually got some very large bolts here. And these are obviously going to be long enough to go through the 15 mil and this. At least I'm hoping they are. Just barely. So yeah, and these actually came with the P1 when the mount came. So that's why they're so long. They knew over at SimLabs that, yeah, this is a thick mount and you're going to need some very large or long bolts to get that started. So let me push this back out of the way. And how I do this is I'll actually take this mount and stick it over here like this. And I am going to, let's see, let me rotate this a little bit. Might help. There we go. I'll just hold it right there. And I'm just going to take a clamp, a regular C-clamp from woodworking and such, and take this bracket and bring it off enough and kind of get the angle right so this is kind of square to where I've got plenty of room to reach in and get to those bolts from the bottom. And you'll see what I'm talking about once I get this set up. And it just takes this here, this clamp. If you guys have ever used clamps like this, you know once you cinch one of these down, especially with this little rubber mat I have under here compressing, yeah, this still moves, right? But it's still good enough to put the motor on there and bolt it down. So that's what we're going to do. Remember, this is a 22-pound motor, or 10 kilos. So yeah, this is a very heavy motor. And you have to be careful what you're doing. You don't want it to slip and get away from you and then mess your whole world up real quick. So I'm just going to set this down on top of it. And we may see it move a little. Well, it didn't rock that much. So now I've got the holes lined up. So everything's lined up here. All I got to do now is start getting my bolts in, and hopefully they're going to be long enough. We're about to find out. If not, then I'll have to go to the store, my friendly neighborhood hardware store, and source some even longer bolts. But look at that. Beautiful, man. Just enough. And remember, these bolts, I'll take this back out, these nuts I'm using have the nylon safety anti-vibration stuff in there, like a lock nut. So that lock nut has got to get to that part of the nylon, this bolt does, for that to take effect. If you can't get far enough for that, then you got a problem. So it looks like everything's looking good there, so we can take the rest of these. And you hear my little bell over there from my bolt holder. I love that thing, magnetic tray that holds my bolts. Okay, so yeah, this is lining up great. Actually, things usually don't work this well, and you're always having to file something, drill something. But yeah, this is, I wasn't sure this was going to work, and I'm very pleased it is. Let me go around here and get these two guys going. And this will be real fast once I get these started, because I have a system of using a driver and a 13 mil wrench, because that's the size of these nuts, to tighten everything up real quick. And again, like I said, I do this so much that, yeah, you're bound to develop a little system eventually. Even if you don't want to develop a system, you end up developing a system. All right, so there we go. That didn't take too long. So now all I've got to do is take my little impact driver here, and I actually have a 5 mil hex bit attached to it. And then I'll take my 13 millimeter wrench, and we'll do this one over here, because I think you guys can see that, hopefully. Well, maybe you can't, but that's what I'm doing. I'm trying to, I got a problem already here, though. The nut is so close to the housing here, right in here, that the box end won't fit, so I'm going to have to do it this way. Fortunately, this way it will fit. Right, so let's go ahead and do that, and it should go right in with no problem, and we're going to hear some hammering noise, so bear with me as that happens. Ah, you know what that is? The sound of a secure fitting. So you got to love that. And I'll go ahead and do the same thing to this one. And I love the hammer drill for this because it makes sure that you get everything nice and tight. So let me get my arm out of the way. Beautiful. All right, 2 more and we are done. And this is going a lot better than I thought it was. So I don't have to edit a lot of film. And one more. Beautiful. All right. That's what we like right there. Now, I'm going to push on this as I'm taking the clamp loose, because now I've got over 22 pounds hanging over the edge of my bench here. There we go. So now, just flip it over. Ooh, man, that's heavy. And there we have it. Ready to go. Looks like I got some dirt on my mount. Oh, terrible. So yeah, we got lucky here that these bolts holes actually mounted. You can see they're pretty maxed out though in the groove. You can see, I don't know if you can see that in the cameras there, but in the reflection you can probably see where the other bolts were in the washers, and you can see how much further these guys are out. But yeah, that's great that this works on the Mige also. I was very happy to find that out. All right, so that's it. Now all we have to do is take this puppy over to the P1 rig, mount it in the uprights there that support this motor mount, and then of course we can start putting all of our other stuff on. So when we come back, we'll have this mounted up and see how it looks. So now you can see that we've got the motor mounted on our nice sturdy 15 millimeter thick P1 motor mount. And if you'll notice, I have the spacer sitting on top of the motor because I did not have to use it. The spacer, actually, if you look at the way the screws and the nuts are on this, yeah, they're just poking out the end of the nuts. So if I put the spacer in there, the screws would not have been long enough. I would have had to source some more screws, number one. Number two, I really didn't need it anyway because I didn't need to space around those socket head cap screws that are going into the clamp for the motor shaft. This is a hollow piece here that clears the heads on those bolts, so it wasn't really an issue anyway. So anyway, that's why you see it sitting on top there. You can see all of the cables are nice and secured now. I really like the way these cables secure, very similar to the way the Cole Morgan is. So doing a great job there. And going back over to our main spider web of cables coming off of the SRG P1 rig. Right, so there it is mounted. We'll go fly around here and look at the other side real quick. Really much more of the same, really. Not much else to see. And yeah, so now only thing left to do is go ahead and jump in and start driving it. So that's where we'll be next. All right, here we are in Sebring in iRacing, and we're in the Ford GT 2017. And I'll go ahead and put my SimuCube settings up here so you guys can take a look at that. Doesn't mean you're going to like them, but there they are. And again, there's my in-game settings for iRacing. First thing I noticed when I'm running this wheel, and this is an iRacing, I start with iRacing usually because it's usually the easiest game for me to get some good feeling force feedback out of whatever wheel that I'm testing. And this was no different actually. And you can see that I'm able to react to the bumps quite well with this. First thing I noticed is this motor is much smoother than any Mige motor I've ever had my hands on. And I'm sure it's in no small part due to not only the SimCube board, but also the firmware and probably mostly the SinCos encoder. It really has smoothed this wheel out, and it's almost feeling like a Cole Morgan, if I dare say it. It's really pretty nice feeling now, and yeah, I really like it. So, and I'm able to react, as you can see, and catch all the slides and the little chinks and stuff that you can see me going around these corners and catching. So yeah, in iRacing, this wheel was smooth and very reactive, and I loved using it. So the next one was Assetto Corsa, and we're in the Ferrari GT3. And Assetto Corsa is a hit and miss sometimes with the force feedback for me on this game for some reason. Maybe it's not so much the force feedback, but anyway, there's my SimuCube settings and also the settings in game under the advanced tab that I was using. But this wheel, because it's smooth, it's a lot smoother actually, I think, than the 10,000 PPR encoder wheel that I used before, or motor. I think that is making it a little bit easier to get some satisfactory force feedback out of this Ferrari. I've had trouble in the past with the Ferrari, and I don't think, maybe it's not so much the force feedback of the game that it's given the wheel, but maybe it's just because I'm a little suspect of these tire models on these cars. It just seems they're a little bit more slippery than they need to be, and the tires seem to wear quicker. But that's just me, and that's what I'm feeling through the wheel. But other than that, yeah, Assetto Corsa was not that hard to set up, and for the Ferrari to make it feel decently to where, as you can see, I can handle the slides. Even though it's still a vague feeling car in the handling department, I'm still able to run it pretty hard and catch the slides and make the small corrections that you need to be able to make to keep the car on track and get some decent lap times out of it. Right, so the next game we're going to go to is going to be Project Cars 2, and this will be the PC version. And I'll show you the settings I used on this for the SimuCube driver. There they are. And you can see it's only at 40%, but in game it was actually at 100%. And this was tricky, but you know what? Project Cars 2 is always tricky, trying to get some decent force feedback out of it. But after working with it for a little while, I was pleasantly surprised at what I was able to come up with. And it's the best feeling force feedback that I've had, I think, in Project Cars 2, running all kinds of different wheels, except for maybe my Bodner. And this actually kind of reminds me of my Bodner because of the smoothness. This SinCos encoder is making everything feel so much smoother. It reminded me of the Bodner. Not quite the fidelity and precision that a Bodner has, but then again, this running a Cole Morgan, which is a much better motor, I think, in general than a Mige is. But yeah, this SinCos encoder is doing a heck of a job to do what it does. So overall experience is really great. I was able to control all the cars, and yeah, I'm very impressed with what they've done with this so far. And I can't wait rather to see what's in the future. And yeah, so what we'll do next is, I think we've done everything we need to do on this kit, so we'll get to final thoughts next. Final thoughts on the OSW Direct Drive Force Feedback Wheel Kit from SimRacing Bay. It's been quite some time since I was last able to do a review on OSW wheel system, and I was not expecting to find much had changed from what I had felt from previous OSW units I had used a while ago. And I was pleasantly surprised at how far the OSW project has come. Utilizing the latest SimCube mainboard coupled with the Ioni Pro HC driver board, this combination makes for a very compact and tunable package when it comes to building your OSW wheel project. The best solution currently available, I would say. So, no surprise that Tomo would use this configuration in his complete OSW kits. SimRacing Bay has already made a name for itself by selling these turnkey kits and maintaining a high level of customer satisfaction with the service he offers after the sale. From the EMI-resistant shielded cables he offers to the custom controller box enclosures, Tomo offers top-flight parts for the OSW customer. The SinCos encoder option that came with this kit really impressed me. It takes a Mige motor, not known for its smoothness, to a new level of refinement. I was quite surprised at how this encoder changed the character of the small Mige. Just a much better delivery of force feedback cues than I was expecting. Now showing characteristics that before I had only felt in a Kollmorgen servo. Not a replacement for the Kollmorgen yet, but man, it is getting closer. Which makes the recent news that the SinCos encoder will no longer be available a sad thing indeed. So if you want a SinCos encoder, you better act fast and buy any remaining units still out there in the wild. Overall, I had a great time with this OSW kit, and I can certainly recommend contacting Tomo at SimRacing Bay for your OSW wheel system needs. He's easy to work with and will listen to any concerns you may have about building your own OSW, as well as assembling a turnkey kit to your specifications. The OSW project has come a long way indeed, and hats off to the people behind making the OSW possible. I'm Barry Rowland, and thanks again for watching the SimRacing Garage channel.